It says find all the applicable limits, and there are basically 4 things when we do limits. So the first one is we're going to find the limit as x goes to negative infinity. This is called the end behavior limit, so it's as you go left forever. And instead of writing the limit and then putting this whole function in there every single time, because I have to say what I'm finding the limit of, instead of doing that, I'm just going to say the limit as x goes to negative infinity of f of x. And that's kind of a way to write it correctly but shorthand it a little bit. So if you look at this graph, and we look at the part where x is going left forever, that's right here. And what y value do you think you're getting really close to right there? 0. And if you look up at the work that we already did, that matches the horizontal asymptote. So that answer kind of makes sense. You're getting closer to your horizontal asymptote, and so that is the limit as x goes left forever. We're also going to look at the limit as x goes to the right forever. So the limit as x goes to positive infinity. And what do you notice here? It's also 0. And that's going to be how it works if you have a horizontal asymptote. Typically, those are called end behavior asymptotes because they are going to tell you what your end behavior is, what your limits are there. Okay. Where else do you guys think we're going to want to find a limit?
Negative 3, right?
Yeah, we're going to need to find it at negative 3 because we have an asymptote there. Where else do you think we're going to want to find it? 0 because we have an asymptote there. Where else are we going to find it? 3 because we have a hole there. So we have to find asymptotes for the end behavior, so negative infinity, positive infinity. Then we look for vertical asymptotes. So vertical asymptotes are the next set of limits we're going to find. And this one's going to take a lot of writing because we have to say the limit as x goes to negative 3 from the left, the limit as x goes to negative 3 from the right, and then we conclude whether or not those agree. And we have to do it for that asymptote, and then we also have to do it for the other one. So if negative 3 is right here, and we're coming at it from the left side, we're looking at this piece right here. And so what y number do you have if you have an arrow going down forever? Negative infinity, good. And then if we look at negative 3 from the right, the graph is going up forever, and so what y value is that? Positive infinity. Do those two numbers agree with each other? No, so what do I write? Does not exist. Okay. And then I want to do the other asymptote. So limit as x goes to 0 from the left, limit as x goes to 0 from the right, and then the overall limit as x goes to 0. So if we look at our graph, what do you see on the left side of 0? Positive infinity, that's an arrow going up. What do you see on the right side of 0? We see an arrow going down, so negative infinity. And what is our conclusion there? Does not exist. Okay, and then last we're going to look at the limit for the whole. So we're going to say the limit as x goes to 3 from the left, the limit as x goes to 3 from the right, the limit overall as x goes to 3. And now this one you can plug in, like from the left 2.999 and from the right 3.0001, or you could cheat a little bit. Does anyone know how we would cheat a little bit on this one? We can't plug in 3, right? Because it's going to not exist when we plug it in. What could we do? Use the y value at the whole, right? Because that's what it's going to end up being. Even if we plugged it in on our graph, we're just going to get closer to that value. So the left side is going to be 1/9. The right side is going to be 1/9. And they're going to agree. And that's because of the way that holes work. So you always know that a limit does exist when if you squeeze it from the left and the right, you pop the zit, you know? Yeah? Okay.